Okay, sorry for the interruption. There was some dodgy salesperson at the door. So where were we? Okay, square root of 24. Now 24 is not it's not a square number directly per se, but we can split 24 into 4 and 6. 4 can be square rooted. If you square root of 4, it becomes 2. You put 6 on the inside. Now, the reason I need to do this separately is because, well, that's how the answer is being presented. Once you've square rooted 24, so if that was a squared, then this would be a, okay? And so, sorry, if that was b squared, this would be b. Once again, we got a minus b, a plus b, a is x. A is the x value. Now, b is whatever we got here. Plus 2 square root of 6. Boom. And this is done. Now the last one here, essentially is similar to what we have done in the past. It's just that you don't have a square number. So if 5 is equate to b squared, well then square root of 5 is equate to b. Okay? And so you rewrite it. That entire x minus 1 is basically a. So x minus 1 minus square root of 5. All right, x minus 1 is a, plus square root of 5. I mean, the textbook, they might have the other way around. Doesn't really matter. That's your final answer. Okay, pardon that little blob. That doesn't count. That's your final answer. I mean, of course, on the calculator, you might get it into like a decimal value of sorts, but let's not worry too much about that. So this is example 6 using surds. All right, factorization by grouping. This is, ladies and gentlemen, getting into the what do you call it? Theoretical model. So you got a squared minus x plus ax minus a. So what do we do here? So you need to, it seems to me that you need to factorize them into a group. Well, what group are we looking at? Well, how about we split them ourselves doing this? Can we factorize something out of each thing here? Okay, out of this one here, what's the common factor? It looks like x. I mean, that's all x, so common factor has to be x. Divide each term individually. There's a minus sign in the middle. Divide x squared by x, you should get x. Divide x by 1, divide negative x by x, you get minus 1. Boom. Now, coming across here, ax minus a. Is there anything common? Is there anything common between them? Well, the answer is of course there is. A is the common factor. You take a out, plus a. Divide each of the term in there by a. So ax divided by a is x. Negative a divided by a is minus 1. Oh, here we go again. Now, is there anything common here? Of course there is. X minus 1 seems to be the common factor. Yes, sir. You take them out. All right. What's remaining inside the bracket? Well, x is there plus a. There you go. Final, your final answer looks like this. Now, this particular example is what I classify, there's no official name, is what I classify the double factorization. Double factorization. Because you are actually factorizing this twice. First time is factorizing individual parts of the whole expression. Second time is factorizing whatever you have factorized to get the final solution. Such as in life, a lot of time you have to solve issue twice. Process it, solve it. Now, this entire topic deserves a bit of explanation. I mean, if you look at the work like we've done so far, all of this if you might as well include part A as well. Look at all of these nonsense-looking, seemingly nonsense-looking thing. All right, seemingly nonsense-looking thing here. All right, what is the whole purpose of doing this? I mean, this stuff seems to be stressful enough. Why are we doing any of this? Well, for one, it's part of the school curriculum that you need to know. It's two, by you at least gaining some degrees of mastery over this, this allows you to have much stronger, how should I say, arithmetic processing ability that's required for higher order thinking. Processing large quantities of information by applying a certain procedure. Now, there are, while the question you're dealing with and the info you're dealing with are varied, the procedure is very much the same. So following a strict set of procedure to solve problem is a skill that's absolutely useful in most of the jobs, particularly in the STEM field, but it can be applied in any other field because it doesn't matter what you do. You're running a business, you're running a school, you're running a, like whatever job you're running, be a lawyer, be whatever. Following a certain set of procedure to produce an outcome is very much part of your professional job skill, all right? And so what we are teaching you here is a form of, how should I say, academic arithmetic conditioning that strengthens your ability to follow set rules, follow set procedures, being more resilient, dealing with complex procedure in a systematic way. Because I have no idea what the hell this is, but you still need to follow it because ultimately this will produce something. I don't know what, but it will produce something. And so there will be a lot of time in your life where you have no idea where you're going, but you still need to do a good job in the meantime. All right? Catch you next part.